kind of important. Maybe all that extra heat from the incandescent bulbs can keep it from freezing, and like when it gets ice on it, like if it gets too thick, it's kind of hard to see, or it might make it not work. So that extra heat could be useful.
Yeah. I don't know that ice-covered stoplights was ever that much of an issue, but you're right. I mean, if they were, that would keep the ice melting.
So if everything has like a specific frequency, and it can fight against like different, like a frequency that doesn't match, does that mean that, like if I had UV light shining on something and it spat out something else, that if I shot out something, if I shot like a FM radio wave at it, that it would shoot out something besides heat? Okay. So I mean, depending on what you shoot out.
And what ends up happening if it re-emits, it always re-emits something of the same energy or lower.
Okay.
So you can't shoot an infrared in and get a gamma ray out. The energy, you never create energy. You can't create energy out of nothing. So the energy, the photon that you come out, if it's not a twin, it'll be a lower energy photon.
Okay. So it won't always necessarily be heat. It can be almost anything.
Right.
Okay.
Yes.
So I'm gonna go for Dallin's idea. Can you, like, if you shoot them fast enough or they come in close enough, can you put in like 2 infrared waves or protons and get out 1 gamma ray or something?
And again, we'll talk about why in the quantum unit, but it turns out the answer to that is no.
Are there like substances where if you put in like ultraviolet radiation and stuff like that?
I didn't hear you.
Are there substances like if like you have like a sheet of material and like you put in like UV or anything like that, like you get out visible light, like something will shine if high radiation is put on it?
Yeah. And again, we keep getting into examples that I'm going to talk about in the quant unit. But do you guys remember there used to be some detergent that always advertised that made your brights brighter and your whites whiter?
Yeah.
Okay. What that one did, it had a chemical that was mixed in it that was a phosphor, so that when ultraviolet light hit it, the material would absorb ultraviolet and re-emit energy at a lower frequency. Well, the lower frequency is in the visible. So if you shine ultraviolet light on it, it would emit visible light. And so if your shirt had been washed in this stuff, well, normally ultraviolet light that hits this shirt, bounces off again or re-emits as ultraviolet, which we can't see anyway, so no change. But if the ultraviolet that hits this, and there is ultraviolet light hitting it, re-emitted in the visible part of the spectrum, well, this would appear to be brighter than it would be otherwise. And so the whites appeared to be reflecting more light because they actually were taking the ultraviolet and re-emitting it as visible. And so the color, everything really was whiter and brighter with that because the phosphor was taking the normally invisible ultraviolet light and re-emitting it in the visible wavelength so you could see it more. And sometimes they'll do that with toothpaste also because it wants your teeth to look really, really white. And you can always tell if somebody has that kind of toothpaste if you shine a black light on them. Black light has a lot of UV. And so, if you smile in ultraviolet light and your teeth just really glow, it's because you have that toothpaste that'll have a phosphor in it.
So that would explain...
And it re-emits the ultraviolet in the visible wavelengths.
That explains why, like, when you're under black lights and like maybe you're roller skating or whatever, some people like keep their mouths in the glow. Yeah,
yeah. And some clothes will glow brightly under black light because they have the phosphor or the dye that's in them absorbs ultraviolet and re-emits in the visible.
So is that like safe? I guess like it's absorbing all that like UV or whatever.
Yeah.
It isn't any different than
a story from physics in real life. I can still remember when I was in first grade. You know how when you're in first grade, there are always little things that the teacher does that everybody, oh, I want to do that one. I want to be the line leader. I want to be the, whatever it is. And well, in first grade, I can remember there were several little chores that you always wanted to get to do. And one of them, everybody had to get a vitamin every day. So if you got to be the person who passed out the vitamins, that was a big award. And then we also had health lights. And there was a switch on the wall that you're supposed to turn the health lights on for 10 minutes every day. And that was always a thing, if you got to be the person to turn the health lights on, well, you got to go over and flip a light switch is what it was. But, if you're in first grade, that's a big deal. And so I can remember that. I guess that's probably why it made an impression on me that I remember it, because, you know, if you got to turn on the health lights, and nobody ever questioned it, and later on I, you know, started wondering, well, I wonder why they had health lights, and I wonder why they turned them on for 10 minutes every day. I wondered what was going on with that. And then as I learned more about physics, I realized what was going on. Those lights, I remember them being kind of purpley looking. So basically they were light bulbs just like this, but they didn't have the phosphor on the inside, so they emitted a lot of ultraviolet light. So ultraviolet light is harmful to biological things, like bacteria, stuff like that. So I'm sure somebody got the idea that if we shine ultraviolet light, it will tend to kill bacteria. It'll be like a disinfectant. And if we do that in the schools, then our kids are going to be less likely to get sick, our kids will be healthier. We only turn it on 10 minutes a day because we don't want to overexpose the kids to ultraviolet light. So I'm sure that some salesman got that idea and sold the school on the idea that your kids will be, your students will be healthier if you shine these health lights for 10 minutes every day. Because I never saw them anywhere else later on, and thinking back on it now, I think it's probably kind of a silly idea. But somebody probably convinced the principal or somebody that that would be a healthy thing for the kids. So you know, it's kind of that same concept that you were asking about.
What? Conning people?
No, about taking ultra high energy light and re-emitting it and using that energy to do something else, like in this case, kill bacteria.
Yeah.
The blue LED was made in 2002.
2002.
So 11 years ago.
So, yeah.
The guy made
Time
$200
flies as you
million.
get older. See, that's one of those things I would have thought, oh, that's probably in the last 3 or 4 years.
That's a lot.
But 2002, that's, you know,
Still a lot.
that's 11 years ago now. So. All right. By the way, that's the kind of thing that maybe you guys can take advantage of situations like that I was not able to. When that happened, I remember reading in the technical journals that they can now, that could produce blue LEDs, and I knew, well, immediately, if you can produce red, green, and blue LEDs, you can produce true color. There's going to be a big boom. If I had money, I would invest it in this company that produces blue LEDs, but, you know, I'm a teacher, didn't have all that much money at the time. But had I had the money, I would have been invested in that, just because I know that that makes a lot of other technology now possible. So, see the value of education. If you have money to invest, sometimes you can make more money with that. But if you didn't have the money in the first place,
Well, see, what you need is an education, and then the economy count somebody from Hollywood out of that money.
could be. That could work. All right, so anyway, where we left off. Let's see, back to the computer.
They're just about the stupidest city in America, other than maybe DC.
I'm from
So
Los
in terms
Angeles.
of transmission or
It's like-
transparent
I'm not talking about California,
and
I'm
opaque
talking about
materials,
Hollywood.
That's
we've
Los
talked
Angeles.
about the effect of absorption and re-emission, what resonance has to
it's
do
not.
with anything,
God, you suck.
and then the speed of light in vacuum, the
It's not
speed
bad,
times
but
10
thank you for
8 meters per
that.
second. But when light is traveling through some other material, like some other transparent material, then it is always less than it is in a vacuum. And the reason why for that is because that absorption re-emission process takes a little bit of time. And so the more time that that takes in the material, the longer that the molecules hang on to that energy before they re-emit, then the slower the light travels, or the average speed of light is in that material. Okay. So I think we had covered most of this other stuff. We talked about the polarized light the other day. Talked about the color and the dominant eye and all that.
Why are you doing it all like out of order?
What?
Why are you doing the slides out of order?
Because those are the way the discussion came up in class.
Oh,
Usually somebody would ask a question and would relate to some topic, so we would talk about that.
oh
So
okay.
it's just the way the discussion flowed. I want to make sure that we talked about everything. I'm going to come back to that website just because it's kind of a cool one. The one piece that I wanted to show you. Oh, it's coming up on the next slide. Okay. The next slide then is just kind of, to me, it's one of those kind of neat effects that plays, or that comes about because of the pigments in the retina of the eye that absorb specific wavelengths of light, and then they re-emit that, or they send the signal through the optic nerve to your brain. And if a cell gets tired, it ends up that cell will send a weaker signal to your brain than the other cells around, and as a result, colors can end up changing. And this next thing is going to be kind of a cool effect that illustrates that. I'm going to hit the slide. It's going to bring up a picture that you'll recognize of the American flag, but the American flag is a little bit bizarre. And what I would like for you to do, I'm going to have you stand up somewhere, get to a position where you can see it nice and easily, and I'm going to have you focus right there on that star, okay? So what I'm trying to do here by having you focus on that star is keep your eyes fixed exactly on that one spot.